Surveying Field Work CE 2704. I am Siddharth Das, roll number 120 CE 0054. Problem that is assigned to me is example number 3.13. The problem statement states that there is a rectangle named ABCD in which A, B, and C are stationed where staff reading were obtained with a label set up at E and D. The observed reading are given in table 3.14. The level setup are setted at E and D and staff reading are obtained of station A, B and C. The level setup at E and staff reading of A is obtained as 1.856, of B is 0.809, at D of A is 2.428, of B is 1.369, of C is 1.667. If A is a benchmark having elevation of 150 meter, calculate the correct elevation of B and C. Means in this question we need to calculate the correct elevation of B and C. As given in the question, the staff, we will first look what is label staff and how staff reading are taken. A label staff is a measuring rod which lands surveyor sight through a telescope to calculate the slope or difference in elevation between two locations, whatever their material construction. Most all model can be adjusted in height either telescopically or with additional sectional attachment, also called a leveling rod. Its use is based on one of the simplest principle of geometry. After this, we will look how staff reading are taken. As shown in this diagram, it shows that how two surveyor are taking the staff reading and how label setup is being setted in a surveying ground. Now coming into the solution of the problem, as we can see in the diagram that angle DAB is 90 degree. So from Pythagoras theorem we can calculate the distance of the hypotenuse EB in triangle BAE and the hypotenuse BD in triangle BDA. The hypotenuse EB is equal to under root of base 15 square plus hypotenuse 20 square. Result comes out to be 25 meter, and similarly hypotenuse DB equals under root of base 48 square plus hypotenuse 20 square is equal to 52 meter. Now assuming the line of sight to be inclined upward by angle theta, that is angle BAEA and angle BDA to be theta, the correct staff reading on A when labeled at E is equals from table 1.856 minus 15 theta. The correct staff reading on B when labeled at E is equals from table 0.809 minus 25 theta. The staff reading on A when labeled at D is equals 2.428 minus 48 theta. The correct staff reading on B when labeled at D equals 1.369 minus 52 theta. The correct difference in label of A and B from the two instrument position must be equal. Therefore, under bracket 1.856 minus 15 theta minus under bracket 0.809 minus 25 theta is equals under bracket 2.428 minus 48 theta minus under bracket 1.369 minus 52 theta. From here theta comes out to be 0.002 radian. The correct label difference of A and B is equals under bracket 1.856 minus 15 theta minus under bracket 0.809 9 minus 25 theta. This equals 1.047 plus 10 theta. This equals to, as we will put the value of theta obtained in the above step, equals to 1.047 plus 10 into 0.002. This equals 1.067 meter. This is the correct level difference between A and B. The reduced level of B comes out to be the elevation of A plus the correct level difference between A and B, that is 150 plus 1.067, which comes out to be 151.067. The correct staff rating at C is equal to 1.667 minus 20 theta. Putting the value of theta in this equation, the correct level difference of A and C comes out to be uh, under bracket 2.428 minus 48 theta minus under bracket 1.667 minus 20 theta. This comes out to be 0.761 minus 28 theta. Putting the value of theta in this equation, we get the correct level difference between A and C to be 0.705 meter. Now we need to obtain the reduced level of C, which will be the elevation of A plus the correct level difference between A and C, which is 150 plus 0.705 obtained in above step, equal to 150.705 meter. And thus we have solved the problem. Thank you.